This is review for Module 12. Question 1 wants us to solve the system of equations. I prefer elimination whenever possible. I'd like to make my x values opposite. Right now they're the same, so I'm going to take my first equation and multiply through by -1. When I do, I get negative x minus 5y equals -15. Now, when I add the two equations together, x plus negative x is gone. 4y minus 5y is negative y, and 25 minus 15 is 10. If I multiply both sides by -1, I get y equals -10. When I know my y value, I can plug it into the equation, one of them, and find the x value. Let's use the first equation. X plus 5 times -10 equals 15. X minus 50 equals 15. Add 50 to both sides, and x equals 65. We could check by plugging in our answers for x and y into the equation we didn't just use, which is the second equation. So I take my x value of 65, and I'm going to plug in my -10 for y, and that should add up to 25. I've got, plugging in a -10, I've got 65 minus 40, and that does indeed equal 25. So I've checked my system of equations. Question 2. You've got $7.20 in quarters and dimes. There are a total of 39 coins in all. How many of each coin do you have? Well, believe it or not, we've got enough information here to write two equations. I do know my quantity of coins, quarters plus dimes, total 39 coins in all. That's my quantity. Now the value. Well, a quarter is worth 25 cents, or 0.25. 0.25Q. A dime is worth 10 cents, 0.10D, and that should add up to my total value of $7.20. And you know me, I really like elimination better, so I'm going to multiply my top equation through by -0.10. I'm choosing the smaller of my two coefficients, and I'm using the opposite, -10. When I distribute that -10 to every term, I get, that is a Q by the way, I get a -0.10Q minus 0.10D, and that equals a -390. Now I'm set to add the two equations together. 0.25Q minus 0.10Q is 0.15Q. The dimes eliminate, that was the plan, and my money adds up to, $3.30. Now divide both sides through by 0.15. And it appears my number of quarters is equal to 22. Now that I know my number of quarters, I can go into the easy equation, plug in the 22 plus my unknown number of dimes, and know that it needs to add up to 39. Subtract 22 from both sides, and we discover that D is equal to 17. If I were you, I would check this problem in the equation we didn't just use, which is this one here. 0.25 times 22 plus 0.10 times 17, and it's supposed to add up to 720. And when you plug those both into your calculator, you find that it does add up. Okay, number 3, we're going to find out if each ordered pair is a solution to the system. That means we've got to plug in each ordered pair to both inequality and get a true statement before we know that we've got a solution to the system. So let's take the ordered pair 6, 6 and plug it into the first inequality. Plugging in 6 for y, is that greater than 0.5 times 6 for x plus 1. Well, we've got 6. Is that greater than 3 plus 1? Is 6 greater than 4? It is greater, so far it looks like it could be a solution to the system. It's a solution to the first inequality, but we've got to find out if it's a solution to the second inequality. So again, we're going to plug in 6 is less than or equal to 2 times, we're plugging in 6 for our x, minus 2. So is 6 less than or equal to 12 minus 2? And is 6 less than or equal to 10? 6 is less than or equal to 10. So since our ordered pair worked in both inequalities, the ordered pair 6, 6 is a solution to the system. Now we're going to do the same for each of the ordered pairs. So let's plug in 4, 3 into the first inequality. Plug in 3 for y. Is that greater than 0.5 times 4 plus 1? Is 3 greater than 2 plus 1? 3 is not greater than 3. Since the ordered pair 4, 3 is not a solution in the first inequality, there is no way it could be a solution in the system, and we get to stop. Choice B is a no. All right, let's do the next ordered pair. Let's plug in 4, 6 into our inequality and see what we've got. So when I plug in 6 for y, 0.5 times 4 for x plus 1, is 6 greater than 2 plus 1? 6 is greater than 3. So it works in the first inequality. Let's go check the next inequality. Plug in 6 for y. Is that less than or equal to 2 times our 4 for x minus 2? Is 6 less than 8 or equal to 8 minus 2? Is 6 less than or equal to 6? Well, 6 isn't less than 6, but it is equal to, and we have the choice of or. It works in the first inequality. It works in the second inequality. So our ordered pair 4, 6 is a solution to the system. Let's check our last ordered pair. Okay, let's plug in to our first inequality. A 1 for y. Is that greater than 0.5 times negative 2 for x plus 1? Is 1 greater than negative 1 plus 1? And yeah, 1 is greater than 0. So it works in the first inequality. Let's check it in the next one. Plugging in the ordered pair. 1 for y. Is that less than or equal to 2 times negative 2 for x minus 2? Is 1 less than or equal to negative 4 minus 2? Is 1 less than or equal to negative 6? Since our last ordered pair works in both of our inequalities, the ordered pair negative 2, 1 is a solution to the system. On question 4, they want us to write the system of inequalities represented by the graph below. So let's do A first. I'm going to look at this solid line right here. I see I've got a y-intercept here at 2. My slope is positive. The line is going uphill, and I can check. I can rise 1 and run 1, 2. Rising 1, running 2. I've got a slope of 1/2. And so now I know the equation of the boundary line is y is equal to 1/2 x plus 2. And always double check. My line looks uphill. I've got a positive slope. That's a good thing. And you put the rise over the run. Now I've got to decide which way it's shaded. Can you see how over here I am shaded below this solid line? That means that y is less than. Because I have a solid line here, I know that it is also equal to, and that is the inequality for the solid line. Now we can do the one for the dotted line. For the dotted line, I can see this line is going downhill and I have a negative slope. My y-intercept is down here at -3. And if I fall 1, 2, I can run forward 1. So I'm falling 2 and running forward 1. I've got a slope of -2. So I know the boundary line is y equals -2x minus 3. Now I've got to decide which way to write my inequality. I know I'm not going to have an equal to bar because this is a dotted line. And I notice that if I look at this line, I am shaded below that line. That means that y will be less than -2x minus 3. Okay, let's look at the graph on B. Let's look at the solid line first. I've got a y-intercept. My B is 3. And I see this looks uphill. And let's count my slope. If I rise 1, 2, +2, I can run forward 1, 2, 3. So I know my m on this line is 2/3. And the boundary line, therefore, is y is equal to our slope of 2/3 x plus our y-intercept of 3. Now I've got to decide which way to write my inequality. Well, my line again is solid, so I know I'm going to have an equal to bar. Now which way to face the inequality? You can see that the line is shaded above, and that tells me that y is greater than or equal to 2/3 x plus 3. Now let's do the dotted line. On the dotted line, I see I've got a y-intercept at -3. My slope appears to be downhill, so I know it's negative. Let's pick some points that are on crosshairs. If I go from here to here, let's see. If I go down 1, 2, 3, 4, that's a -4. I can go forward 1, 2, 3. So it appears my slope on the dotted line is a -4/3. So when I write the boundary line, I know that y is equal to -4/3 x minus 3. And I'm not going to have an equal to bar on this dotted line here because it is dotted. Let's decide which way to shade. Well, you'll notice that the shading is above the line, so I know that y is greater than -4/3 x minus 3. Let's do the last set on graph C. All right, let's start with this less steep line. I can see that that line is going downhill. I know I've got a negative slope. My y-intercept is at 1. Let's calculate the slope. If I fall 1, I run forward 1, 2. So I know my slope is equal to -1/2. So let's make that a boundary line. I know that y will be equal to -1/2 x plus 1. And I've got to decide. I know, well, solid line, I know it's equal to. Now for this line, can you see how the shading happens below the line? That means that y is less than. And of course, because we have a solid line, I know it's also equal to. Now let's look at the other line. I'll highlight the other line in blue. Again, it's also solid. I know it'll be equal to. It's also downhill. In this case, we have a y-intercept down here at -1. And let's calculate the slope. If I go down 1, 2, 3, so down 3 is -3, and forward 1, 2, I know I've got a slope on this blue line of -3/2. So the equation of the boundary line is y is equal to -3/2 x minus 1. Again, it's a solid line, so I know that I will be equal to. On my blue line, you can see I'm shaded above the line. That means that y is greater than or equal to -3/2 x minus 1. All right, question number 5. Does each system have at least one solution? What I'm going to do in each case is make a quick sketch. Notice on the first couple of problems our slopes are parallel. So there is that possibility of not having a solution. Let me draw a coordinate plane. Let's call the first line here my blue line. I've got a y-intercept of 1. My slope is a negative 1/3. It better look downhill and not too steep. So let's say that that is my blue line. It says that y is less than, which tells me I'm shading below. And now let's call my second line the red one. It has a y-intercept at 5. I'll say that's about there. It should look parallel because the slope is the same. So let me try to make that look parallel. Excuse me if it doesn't. I made that one dotted, but I need to add a solid line because in this case, there's an equal to bar. Y is greater than in this equation. That means I'm shading above. So we have overlap, and that means, yes, there are many solutions, all where the overlaps are. All right, let's look at problem B. Again, I've got parallel lines. Let me draw my coordinate plane. On the first one, I've got a y-intercept at 2, a slope of 5, which is fairly steep. I'm going to fake it. We'll call this my slope of 5. It doesn't really matter. And I am greater than, y is greater than, so I'll be shading above. On the second line, we'll make that one our blue line. I have a y-intercept of 0, and my slope is 5, so it's parallel. That one's also a solid line, and it says that y is less than. That means I'm shading below. Since my shading does not overlap, I have no solutions on problem B. Okay, let's look at C. Again, we are parallel. We have slopes of -1. On the first one, I have got a y-intercept of -3 and a slope of -1. So I've got to make sure it looks downhill. It'll be a dotted line. And it says y is greater than. That means I'm shading above. On the second line, we'll make that one our blue line. I've got a y-intercept this time at -1. I know it needs to look parallel because our slopes are the same. In this case, it says y is less than. So once again, we've got overlap. And that means, yes, there is a solution. It all happens within this region. All right, let's look at the last two. I'm going to graph the last pair of inequalities. I'm going to graph them, although I'll show you in a minute why I didn't actually need to graph them. All right, on the first one, I've got a y-intercept of +1. My slope is -2, so it should look downhill and relatively steep. It's a solid line because I've got the equal to bar. And it says that y is less than or equal to, so if y is less, that means I'm shading below. Now let's graph the second line in blue. I've got a y-intercept of 1, just coincidence, same y-intercept, and I've got a slope of +1/2. That means it's not very steep, and it is uphill. It's a dotted line because I don't have an equal to bar, and it says that y is greater than, so I'm shading above. And clearly we can see there's an overlap region right here between the red and the blue lines. So yes, we have more than one solution. And I'm going to tell you why I didn't even need to graph these. As soon as I have different slopes, doesn't matter if they're both positive or one positive, one negative, that doesn't matter. As soon as the slopes are different, I know that the lines will cross, and I know that there will be areas of shading that overlap, and that means there would always be multiple solutions. On question 6, we are to find which of the following ordered pairs is not a solution. So really, let's just go plot them all and see where they lie. On A, we've got -3, +1. That's this ordered pair here. It's within the shaded region, so we know, yes, we have a solution. On the ordered pair 0, -2, that is right here. That's on the line. It's in the shaded area on the line. Because that line is a solid line, the ordered pair 0, -2 is a solution. Now let's plot the point -6, 4. -6, +4 is right here, and yes, that is within the shaded region. And our final point is -4, 4. -4, +1, 2, 3, 4, right here on the dotted line. Because it's a dotted line, this ordered pair here is not a solution because it was on the dotted line. One more point I'd like to create. Any point on this solid line up here away from the shaded region would also not be a solution. Question 7. Your school bought 16 laptops and tablets for a total of $4,535. Laptops cost $310 each and tablets $225 each. How many of each did the school buy? Well, we can write a system of equations to solve for this. The first equation I like to write is the quantity equation. I know that I've got 16 in total. If we call our laptops X and our tablets Y, then I know that X plus Y will add up to 16 devices in total. Now we can take into account the cost of each. The cost of a laptop is $310 times X number of laptops plus the cost of a tablet of $225 times Y number of tablets. That'll add up to our total cost of $45.35. Now the book would have you solve this using substitution because I've got an understood 1 in front of the X or my Y, either one, but I really still prefer elimination. So I'm going to take my top equation and multiply by the smallest of the two coefficients, but its opposite value, which is -225, and I will distribute that to every term on both sides of my inequality. And when I do, I get a -225x minus 225y, and that equals -3,600. And now I can combine my two equations. 310x minus 225x is 85x. These two eliminate. That was our plan. And when I combined 4535 minus 3600, I get 935. Divide both sides by 85. And I find that x equals 11. And that would be 11 laptops. Well, I can go into my easy equation. If I've got 11 laptops, plus an unknown number of tablets, but total I've got 16, subtract 11 from both sides, and my number of tablets should be 5. 5 tablets. I should always check. I just used my quantity equation to get my number of tablets, so I really should use my cost equation to make sure that I really am spending $45.35. That's a great check. So 310 times 11 laptops plus 225 times 5 tablets better add up to $45.35. And check on your calculator. It does. 35. We're good. In question 8, we are to find how many solutions the systems have, and we're supposed to explain as well. Well, one of the easiest things you can do is get both equation into slope-intercept form. I can see that the second equation is already in that form. So let's take our first equation and get it that way. Let's subtract x to both sides. And I've got minus 3y is equal to minus x minus 6. Now let's divide every term through by -3. And I get that y is equal to positive 1/3 x plus 2. Well, when I compare that to the first equation, I see that, yeah, they are parallel, but they have different y-intercepts. They have different, let me rephrase, they have the same slope, they have different y-intercepts. That means they have no solution, and the reason is because they are parallel. I'd say the reason is because they are parallel. Okay, on part B, let's again get these into slope-intercept. On the first equation, I would subtract 10x to both sides, and I get 5y equals negative 10x plus 15. Divide every term through by 5, and I've got y is equal to negative 2x plus 3. Now on the second equation, that's in point slope. I hope you recognize it. We can distribute the negative 2. So y plus 3 equals negative 2x plus 6. Subtract 3 to both sides. And y is equal to negative 2x plus 3. Well, they have the same slope. Might make you think that they're parallel. But they also have the same y-intercept. So these are actually the same line. Picture it. If I were to graph them with a y-intercept of 3, here's the first line. Graph the second line right on top of it. There are infinitely many solutions. Infinite. The reason is because they are the same line. The one example we didn't see would be if the two lines had a different slope, but as you recall, in that case, if I had one line with one slope and a second line with an entirely different slope, they would cross and have one solution. Their y-intercepts may or may not be the same. It doesn't really matter. If they are the same, as in the picture that I just drew, the point of intersection would happen on the y-axis. Question 9, Bob the plumber and Plumbing Paradise both charge a flat fee plus an hourly rate. That tells us we can write an equation in slope-intercept form. Let's call B of x the total cost using Bob's, B for Bob, and P of x will represent the total cost using Paradise, P for Paradise. We are told to write a system of equations to represent the situation and find out how many hours will it be when they charge the same amount. And what we've got here is a compound t-chart. I've got my x values, which would be my number of hours, and I've got my y value for Bob's and my y value for Paradise. Well, let's deal with Bob first. In order to write an equation in slope-intercept form, we need to calculate slope first. So to get our slope, we will use y2 minus y1, 440 minus 200, over x2 minus x1, which is 6 minus 2. Our numerator becomes 240, and our denominator is 4, and we've got a slope of 60. When we know our slope, and yes, we've got some ordered pairs, we can plug those into y equals mx plus b. Our m value would be, our y value would be 200 equals, our slope is 60, we just calculated it. Our x value is 2, and it's the b we don't know. Our flat fee is unknown at this point. 200 equals 120 plus b. Subtract 120 to both sides, and we discover that b is 80. So now that I've got m and I've got b, I can write the equation for Bob. In place of y, I'll use b of x. And that is equal to our slope of 60 times x plus our y-intercept of 80. And that's the equation for Bob's. He charges an hourly rate of 60 and a flat one-time fee of 80. Now let's do the same thing for Paradise, and I'll use green for Paradise. Okay, for Paradise, again, we need to get m, and that is equal to 430 430 minus 210 over 6 minus 2. 430 minus 210, that's equal to 220 over 4, which is equal to 55. Our slope is 55. Well, now that we know m, and we can use an x and a y and plug them into our slope-intercept formula, a y value of 210 is equal to a slope of 55 times an x value of 2 when we add that to our b, which at this point is unknown. Well, let's simplify. 210 equals 110 plus b, subtract 110 to both sides, and we discover that our y-intercept is 100. Well, now that we have b and we've calculated m, we can write the equation for Paradise. So p of x equals the slope of 55 times x plus our y-intercept of 100. At Paradise, the flat fee is $100 and the hourly charge is 55. And that's our system of equations. That is the answer to part A. Now to answer part B. When do the hours, or excuse me, after how many hours do they charge the same amount? Well, that's easy. That's when I want to find out, when does P of X equal B of X? I can use substitution, and in place of B of X, I can write 60X plus 80 is equal to 55X plus 100. Let's subtract 55x to both sides. And I get 5x plus 80 is equal to 100. We'll subtract 80 to both sides mentally. We get that 5x is equal to 20. And if we divide both sides by 5, we've got x is equal to 4. Now remember, x was our number of hours. So let's give units here. We know that in 4 hours, the two companies will charge the same amount. Well, they also want to know, what will that amount be? So we can take the 4 hours and plug it into this equation or plug it into this equation. Whichever one we plug it into, we better get the same answer. As a matter of fact, I'm going to plug it into both because that will also be a fabulous check. So let's plug in, oops, excuse me, let's plug in 60 times 4 plus 80 and hope that that equals 55 times 4 plus 100. Well, 60 times 4 is 240 plus 80, and 55 times 4 is 220 plus 100. 240 plus 80 is 320, and 220 plus 100 is 320. So not only have we checked our problem, we've also found out that in 4 hours, both companies, so I said that in 4 hours, both companies charge $320. Okay, on number 10, we are going to graph our system of inequalities. Let's graph the first one in green. We've got a y-intercept here at -1 and a positive slope of 2/3. I'm going to rise 2 and run 3. Rise 2 again, run 3. Fall 2, run backwards 3. Fall 2, not room to run backwards 3 again. I'm going to hand sketch this for speed's sake. It's a solid line because I've got the equal to bar, and because y is greater, I know that I am shading above the line. All right, let's make the second line in red. We've got a y-intercept Okay, I'm going to start this one again. I've got a y-intercept on the first one of -1 and a slope of positive 2/3. I will rise 1, 2 and run 1, 2, 3, fall 2 and run backwards 1, 2, 3. Connect that with a solid line because it is equal to, and again, because y is greater than, we are shading above the line. Now we'll graph the second line. We've got a y-intercept this time of +1 and a slope of +4. That's a steep line. Rise 1, 2, 3, 4, run 1. Also fall 1, 2, 3, 4, and run backwards 1. And that is a positive steep line. However, I did mean to make that one dotted, so that's the beauty of using pencil or something erasable. We can erase part of that line and make it appear dotted. Now, this one says that y is less. That means we need to shade below the line. Well, the area of overlap is this region right here. And every point within that region is a solution to the system. So we are told to give 2 ordered pairs that are solutions and 2 that are not. Well, you can make that easy on yourself. Here's a solution here, and that would be the ordered pair 2, 1. Another solution could be 2, 2. And then non-solutions could be 1 out here, which would be 3, -2. And how about 1 over here? This would be -3, -4. Okay, on our second set of systems of inequalities, we've got a y-intercept here at +3. Our slope is negative, so I can fall 1 and run forward 1, 2, 3, 4. Also rise 1 and run forward 1, 2, 3, 4. And I want a dotted line. And this says y is less, so I will shade below the line. I'll do the second line in red. It's got a y-intercept at -2. Our slope is again negative. It's a -1 slope. I can fall 1 and run forward 1. I can also rise 1 and run backward 1. This is going to be a solid line because it has the equal to bar. And this one says that y is greater than. So that means I will be shading above. And where the colors overlap, which would be in this region here, is where we have solutions to our system. So let's go ahead and give some ordered pairs that are solutions. Make it easy on yourself. 0, 0 is a solution. So is 1, 1. Now let's pick some that are not solutions. How about -3, 0? And another non-solution could be up here at 3, 4. Alejandro has 2 summer jobs. He earns $8 per hour babysitting and $12 per hour washing cars. He cannot work more than 20 hours per week and would like to earn at least $200 per week. We're told to write a system of inequalities that represents this situation, and when we're done, we're going to find out if 10 hours of babysitting and 9 hours of washing cars will help him to reach his goal. Well, first let's call babysitting B, and we can call washing cars W. And we know that he can't work more than 20 hours. So all of my babysitting hours plus all of my car washing hours has to be no more than 20. I can work 20, and I'm also happy with 19 and 18 and 17 if I'm Alejandro. Can't work 21. All right, now let's take into account what he earns doing those jobs. $8 per hour times a B number of hours babysitting plus $12 per hour times W number of hours washing cars, and we want to make at least $200. That means I'm happy with 201 or 200, so I should have greater than or equal to 200. Now I've got my system of inequalities, and I can graph them, or In this case, I don't need to graph them. It didn't ask me to. It just wants to find out, can I work 10 hours babysitting and 9 hours washing cars and reach the goal? Well, first of all, let's make sure that it's not too many hours. I know that 10 plus 9, is that less than or equal to 20? Yeah, it's 19. We're good. So we're satisfying the first inequality. How about the second one? 8 times $10 per hour plus $12 per hour rather times 9 hours of washing cars. And I'm hoping to make a minimum of $200. So we've got 80 plus 12 times 9 is 108. Is that greater than or equal to 200? No, we've got 188, and that does not reach our goal of $200. So part B is a no, doesn't reach its goal.